Okay, I think the most common mistake on this one, so let me just address that first. I've seen this on a lot of exams, that people will write the answer 1/4 cosine to the 4th x plus c, right? But the c is not really the issue here. The problem with that is if you differentiate it, you've ignored the chain rule. The 1/4 is a spectator. Differentiate with respect to cosine x, and I get 4 cosine cubed x. Looking good so far, and then I realize, oh, the chain rule says I have to differentiate the cosine function with respect to x and tack that on. So if I think this is the answer, what happens? I missed by a factor of sine x because I ignored the chain rule. All right, so this is a dead end. What I need to do is manipulate this thing using trig identities. And what you'll notice in the textbooks is that some of them try to come up with a flow chart for you to memorize of how do you handle a cosine to an even power, how do you handle a cosine to an odd power, how do you handle an integral that has a sine to an odd power multiplied by a cosine to an even power, and so on and so on. And I think it's just more effective to get some fluency, just trying different trig identities, and you'll get a good intuition for which direction to go without getting overwhelmed by a huge flow chart. So the standard trick on this one, like my attitude is just with a little bit of experience, you just try stuff and you do a lot of practice problems, and pretty soon you're trying the right thing on the first try. But this is a pretty standard trick. Split off a cosine squared. And the whole point of that is that there's a Pythagorean identity, sine squared x plus cosine squared x equals 1, and that means cosine squared x is 1 minus sine squared x. And maybe that's a useful thing. So I'm going to write my cosine squared as a 1 minus sine squared. And hopefully you see that good things are about to happen. And I have two terms in my integrand now. One of them is cosine, and I know for sure I can integrate that. And then I have another one. It's the cosine multiplied by sine squared. All right, so finding the antiderivative of the cosine piece, that's just the sine function. How about this piece? There's the square of the sine function sitting right next to the derivative of the sine function. I could even just pause for a second and rewrite this as an integral. I don't want you to have to do an explicit substitution to solve this. This is the kind of integrand where I should be able to see the chain rule backwards. So I have a power of sine sitting next to the derivative of sine, which means I've taken care of the consequences of the chain rule, and I'm just looking at this like it's just a u squared, and it integrates to 1/3 u cubed. So if I do a quick check mentally, so this is like inside my brain, a quick check on this piece, the derivative of 1/3 sine cubed x. You're going to differentiate with respect to the sine function, so you get 3 sine squared x. Then the chain rule says you've got to tack on the derivative of sine with respect to x, which is a cosine. All right, so that 1/3 piece right here differentiates to the integrand it came from, so I know for sure it's correct. Okay, so in summary, it's a very standard trick to split off like the square of a sine or a cosine and use a Pythagorean identity. Same for secant and tangent.